Okay, in section 6.4, we're talking about graphs of logarithmic functions. But first, let's talk about the domain of log functions. So when we were talking about exponential functions, we defined it as y is equal to b raised to x, and x was a real number and b was greater than 0, so it wasn't 0 and it was a positive number, but it couldn't be 1. So the domain of an exponential function was all real numbers, and the range went from 0 to infinity, because what it looked like was something like this right here. Okay, so our domain went from negative infinity to positive infinity, but our range got closer and closer to 0 and then went up to positive infinity. Okay, now logs and exponential functions are inverses of each other, so that means that the domain of exponential functions is the range of log functions, and the range of exponential functions are the domain of log functions. Okay, so like it says right here, the domain of a log function is really the range of an exponential function. So the domain of a log function goes from 0 to infinity, and the range of a log function, which is really the domain of the exponential function, that is all real numbers. So if we're trying to find the domain of a log function, then what we're going to do is we're going to set what's inside the parentheses to be greater than 0 and then solve for x. So like this one right here, find the domain and the range of log of base 2 of x plus 3. So what I'm going to do is first I'm going to find the domain. So I'm going to take what's in the parentheses and set that greater than 0 and then solve for x. So the x is greater than negative 3. Okay, so if we write that in interval notation, it can start at 3 and go up to positive infinity. Now notice I don't have an equal sign under this, so it has to be parentheses and not a bracket. Now the range for this is just going to be all real numbers, so from negative infinity to positive infinity. Okay, so there's your two answers right there. Okay, now let's look at this one. We're going to do the same thing. We're going to find the domain and the range of a log of base 5 of x minus 2 and then plus 1. Okay, so the domain, all we're going to do is take what is in the parentheses, set that greater than 0, and then solve for x. Okay, so x is going to be greater than 2, so we can start at 2 and go up to positive infinity. And then for our range doesn't change, it just goes from negative infinity to positive infinity. Okay, same thing here. I'm going to find the domain. So that'll be 5 minus 2x greater than 0. So I'm going to add 2x to both sides. So 5 is greater than 2x. Divide by 2. So 5 over 2 is greater than x. So if I switch that around, okay, x is less than 5 over 2. So that will be from negative infinity up until 5 over 2 for your domain. And again, your range is going to be negative infinity to positive infinity. Okay, now natural log, remember that's just log of base e of 1/2 minus x. So you're still doing the same thing. You're still going to put what's inside the parentheses, and that's going to be greater than 0. And then you're just going to solve for x. So I'm going to go ahead and move over the 1/2. You can move over the x if you wanted to. Then I'm going to divide by negative 1. So x is now, when I divide or multiply by a negative, we're going to flip the sign. So that will be a positive 1/2. So this would be from negative infinity to 1/2 for your domain. And then your range just stays the same. It's going to be negative infinity to positive infinity. Okay, now let's look at the characteristics of the graph of the parent function log of base b of x. So for any real number x and any constant b that is greater than 0 but not equal to 1, it'll have this following characteristics. It will be a one-to-one function. It will have a vertical asymptote at x equals 0. The domain and the range we've already gone over. it'll have an x-intercept of 1, 0, and a key point of b, 1. It doesn't have any y-intercepts. And if b is greater than 1, it's going to be an increasing function. But if b is between 0 and 1, it's going to be a decreasing function. Okay, so like these right here, here's this one right here. So if b is greater than 1, like we have right here, we have an increasing function. Now notice we don't have a y-intercept. It's getting really, really close to y, the y-axis, but it's never going to cross it, never going to touch it. And then we have the two key points, 1, 0 and b, 1. Now if b is between 0 and 1, then what we have is a decreasing function, like this right here. And same thing, we have x is equal to 0, so that's the y-axis. It's never going to cross it, never going to touch it. And we have those two key points, 1, 0 and b, 1. Okay, now when we're graphing this log function of the form log base b of x, then what we're going to do is we're going to draw and label the vertical asymptote, x equals 0, basically the y-intercept, or sorry, the y-axis. You're going to plot the x-intercept 1, 0, plot the key point b, 1, and then draw a smooth curve through those points, and then you'll state the domain, which is 0 to infinity, and the range, which is all real numbers, and the vertical asymptote, which is x equals 0. Okay, so let's look at how that base will affect the function. So if we're just looking at this one right here, so anytime we don't see a number, we're assuming that is 10. So this is log of base 10 of x. Okay, so that is right here. Notice how all of these go through that key point 1, 0. Okay, every single one of them go through that point. And then if I change it to 2.7, that's e for the base. Okay, so here we have a base of 10, so b is 10 here. Here b is about 2.7 because it's e, and here the base is 2. Okay, so as it gets smaller, this goes further up. So that's 2.7, and then you have a base of 2, so it's going a little bit further up. Okay, but that's how the base would affect the logarithmic function. Okay, so let's say the domain, the range, and the asymptote for this one. Okay, so we're going to put what's in parentheses, greater than 0, so this would be the domain. So x is greater than 0, okay? So then our domain would be from 0 to infinity. Our range would be all real numbers, so from negative infinity to positive infinity. And the vertical asymptote, since it's just this right here, we haven't shifted it or gone up or down or anything, we haven't transformed it. That means that the vertical asymptote is going to be x is equal to 0, and that's it. And this is the graph of that function. Okay, so notice how the domain goes from 0, it gets really, 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 really close to 0, and then it goes out to positive infinity for the x values. And then your range is just going to keep going down, keep going down, keep going down, keep going down forever. So it's going down to negative infinity for the y values. And it's going to keep going slightly up forever. So it's keep going up for your y values. And then notice how it's getting really close to this line right here, but it's never touching it or crossing it. That is your vertical asymptote at x equals 0. Okay, now let's look at this one. Say the domain, the range, and the asymptote, and it would be exactly the same. Your domain would be x is greater than 0, so from 0 to positive infinity. The range doesn't change, so that would be from negative infinity to infinity. And the vertical asymptote, because we haven't transformed it at all, really we just have a base of 1/2, that's just going to be x is equal to 0. Now if we look at that function, okay, so the domain goes from 0, so it's getting really close right here. So at 0, and then going out to positive infinity for your x values. Okay, for your y's, it keeps going up and up and up and up and up and up and up forever, so positive infinity. And it keeps going further down, further down, further down forever, so negative infinity for your range. And then same thing, your function's getting really close to that line right there, which is x is equal to 0. And you notice over here, it went through the point 1, 0, which your two key points back here we said were 1, 0 and b, 1. Okay, so let's go back to this one right here. Our b was 5, so we should have the point b, 1, so 5, 1. Okay, so 5, 1 right there. Okay, and then for this one, our b is 1/2, so we should have the point 1/2, 1. Okay, so here's the first point. There's 1, 0. And then we need 1/2, 1, which I zoomed in. This is the zoomed in version of this right here. So here's 1/2, and there it is. Whoops. Okay, there's 1/2 right there. Go up, and there's 1. So there's 1/2, 1. So there's your two key points. Now let's look at horizontal shifts to the parent function log of base b of x. So if we have some constant and we're shifting it horizontally, this is what it would look like. We'd have log of base b of x plus c. Okay, so this is going to shift the parent function to the left if c is greater than 0, and it's going to shift the parent function to the right if c is less than 0. So what we're going to have is a vertical asymptote of x is equal to negative c, and then it will have a domain of from negative c to infinity, and the range doesn't change because it already includes all the numbers. Okay, so if we had log of base b of, say, x minus c, well then what we're doing is we're moving to the right c units. And if we have log of base b x plus c, well then we're moving to the left by c units. Okay, now the asymptote, since it's moving horizontally, well then your graph, if it's like this right here, there's the parent function. If we move it to the left by, say, 2 units, okay, so move it 2 units to the left, well then it also moved the vertical asymptote. And it also changed the domain because the domain is your x values, and that's what we are changing here. That's the x values. Okay, so if we're going to be graphing the horizontal shifts, if c is greater than 0, we're going to be moving to the left. If c is less than 0, we're going to be moving to the right. And then we're going to draw the vertical asymptote, x is equal to negative c, and identify your key points and plot those, and then we'll have the domain is negative c to infinity, and the range is all real numbers, and your vertical asymptote will be x is equal to negative c. So let's look at this one. We're going to graph y is equal to log of base 3, x minus 2, and state the domain, the range, and the asymptote. Okay, so my base is 3. So we're going to have the point 3, 1. But that is the point for when you have not had any transformations. Here, we have gone to the right by 2 units. So I need to add 2 to this. So this would be 5, 1. And then the other point that we had was 1, 0. But again, since we moved to the right by 2 units, I need to add 2 to this. So this will be 3, 0. So there's 2 points right there. And then we need the domain. So the domain will be x minus 2 greater than 0. Add the 2. So x is greater than 2. So it goes from 2 to infinity. The range will be all real numbers, so negative infinity to infinity. And then the vertical asymptote, before we shifted it, we know it was x is equal to 0, but we moved 2 units to the right, so I'm going to add 2 to that. So x is equal to 2. Okay, so our graph should look something like, and let me move this over just a bit. So we'll go out to